Hello peoples, my name is Shiva Pratap Singh and I welcome here all of you scholars. Today I'm here to continue my lecture series of strength of materials. If you want to see my previous video in which I covered basic points of beams and loads, you can click on the I button. Now I want to express some points about shear force and bending moment and some key points for numericals. So let's do it. Shear force is the internal force applied at any section to convert the FBD free body diagram into forced equilibrium either to the left of the section or to the right of the section in transverse direction. Okay, what is shear force? Shear force is an internal force which is applied at any section. Okay, which is applied at any section. It means that you have a beam, you need to cut here, you have two sections, left section and right sections. You can, for numerical purpose, you can take any of the section for solving the problem. Either you take a left of the section or you take right of the section. Okay, for if let we take a left of the section, then we have forces, some vertical force, some axial force and some moment. For movement purpose, we discuss about movement in a bending movement. Now here we talk about only forces. So in shear force we need to convert this free body diagram into forced equilibrium. So how we do that? We take all the summation of all the forces which applied on the fx, means which applied on the x-axis direction, and which are applied on the horizontal direction, sorry, and sigma f by it is means all the forces, summation of all the forces which applied on the vertical direction is equal to 0. This type we convert this free body diagram into forced equilibrium, okay, by taking either left of the section or taking right of the section in transverse and lateral dissection. This definition also said that the shear force at any section is the summation of all transverse forces either to the left of the section or to the right of the section, right? The summation of all vertical forces and summation of all horizontal forces and summation of all vertical forces, okay, either taking left of the section or taking right of the section. Okay, this is the shear force. This is all about of the shear force. Now we take a bending moment. What is bending moment? The bending moment at any section is the internal moment applied at that section to convert the FBD free body diagram into moment equilibrium either to the left of the section or to the right of the section. Okay, what is it? That bending moment at any section by taking any of the section, left section or right section. Let us take left section. So bending moment of left section is the internal moment applied at that section. Internal moment, this is the moment which is applied internally in this section to convert this FBD into moment equilibrium by taking left section. Okay, it's called bending moment. Also this definition is also said that the bending moment at any section is the summation of all movements either to the left of the section or to the right of the section. Summation of all movements, that means summation of all movements is equal to 0. In here we take summation of all movements and convert the free body diagram into the moment equilibrium. Okay, this is all about bending movement. Now we discuss about some sign conventions of shear force and bending moment. So sign convention for shear force: the shear force is positive if it tend to rotate the beam section clockwise with respect to a point inside the beam of the section. What does this mean? This is the look at this picture. This is the sign convention for shear force. The shear force is positive. This is positive for shear force if it tend to rotate the beam section clockwise. It tends to rotate the beam section clockwise. Look here, it applied force upward here and it move clockwise like this. Okay, so it becomes positive, and similarly as vice versa, if it moves anti-clockwise, okay, if it moves anti-clockwise, then it is negative. Here this force is applied anti-clockwise downward. Okay, or you can easily remember that if there is a left side there is a upward force and right side there is a downward force, then it is positive, and left side there is a downward force and right side there is upward force, then it is a negative. Okay, for the sign convention of bending moment, the bending moment is positive if it tends to bend the beam section concave facing upward, which is also called sagging. What is sagging? When you have a single piece, any piece of anything, piece of material, you bend it upward, concave facing. This is concave facing, and you bend it upward Okay, so so that point is that thing is positive, and if you bend if you bend is downward, which is called hogging, which is convex downward, and that one is a negative. Here is the picture, you can easily imagine this. Okay, or you easily understand this if you have a if you have a compression on upper side, that is positive, and if you have a compression on downward side, that is negative. If you can easily remember by taking these type of some concepts. Okay, and this sign convention of bending moment is for any particle or any material which is placed vertically. Okay, so for this, the sign convention of bending moment may be explained as, if the reference phase get compressed, then it is said to be positive. Okay, the sign convention of bending moment, how is this explained? That if the reference phase, this one is the reference phase, get compressed here, this reference phase get compressed, then it is positive. And if the reference phase get tensed, look at this reference phase, it get tensed, then it is negative beam. Okay, generally the reference force, sorry, here is the reference phase. Generally the reference phase is that phase on which the load is applied. This is a this is some print mistake, I'm so sorry. The reference phase is that phase on which the load is applied, or a reference phase generally is that phase in which force applied. Okay, here this phase you have force applied, so this is the reference phase. Here in this phase you get force applied, so this is the reference phase. Okay, the reference force should be continuous for the whole body. Reference this force is also called reference force. Okay, and this force is also called reference force, and this reference force should be continuous for whole body. This reference force is continuous for whole body. Okay, what is it means? That this reference force is same as here, similarly this same here, same here, same here, every year. This reference force is continuous for whole body. Similarly for this one also. Okay, now what is there is a point when you go for this numerical solving purpose, there is a word called contraflexure in bending moment. So what is the point of contraflexure? In bending moment diagram, the point at which bending moment changes its sign from positive to negative or negative to positive is called point of contraflexure. When you solve the problem, you get some bending moment diagram like this. Okay, like this. Here you only understand, or you only learn about only point of contraflexure. What is it? That in bending moment diagram, the point at which bending moment changes its sign, that point in which bending moment diagram or bending moment changes its sign, here this is the point where bending moment changes its sign positive to negative. That point is point of contraflexure. Okay, it is a point where the beam tend to bend in opposite direction. It is the point at which curvature of beam changes. This is only diagram. In real when we see this point of contraflexure on any material, what happen is that it is a point where the beam tends to bend in opposite direction. That beam which we take, that beam tends to bend in opposite direction. Okay, and when it tends to bend in opposite direction, then that point is the point of contraflexure. Okay, I hope you get this. There is here's some key points for numericals. In the very next video, we try to solve some of the numericals of strength of materials, and some of the numericals about shear force and bending moment diagrams. For those purpose, before solving those numericals, you need to learn these some points of numericals for drawing shear force diagram and bending moment diagram. What is it? That when we have point load, then then the shear force diagram is rectangular, and bending moment diagram is triangular. Rectangular uniform diagram and triangular linear diagram. When we have when we have UDL, then shear force diagram is triangular and parabolic, and bending moment diagram is parabolic. When we have a universally distributed load, then we have a shear force diagram. We get shear force diagram, a triangular shear force diagram, and a parabolic bending moment diagram. What parabolic? 2-degree parabolic. Okay, and we have when we have universally bearing load. Then we have shear force diagram is parabolic 2 degree, and bending moment diagram is cubic parabolic 3 degree. Okay, you can easily learn this by like some tricks like this one. This is same, this one is same. For learning purpose this is same. And we in the very next video we have we also have some more key concepts about for numericals. We have some graphs for doing quick numericals for objective purpose. Okay, in the next video we start numericals about shear force diagram and bending moments diagram. So now thank you so much for watching this video here. If you have any question, any doubt about this video, you can find me at C Schooling 120. And till then, take care, keep growing, hustling hard. Good luck.